Hello friends. In the last video lecture, we have seen what is how the voltage distribution is being done across the string of insulators, and we have also defined one important parameter, that is a string efficiency. We have seen that whatever the voltage we apply across the string of insulators, this voltage will not be distributed uniformly across all the insulator discs. Why? Because of the presence of shunt capacitance. You have understood that there are two types of capacitors. One is a self capacitor or a mutual capacitor, and another one is shunt capacitor. Because of this shunt capacitor, the voltage will not be uniform across the all the discs in the or insulator discs in the string of insulators. So this non-uniformity of voltage distribution is expressed in terms of string efficiency. Then this string efficiency is defined as the ratio of voltage across the whole string of insulators to the product of number of discs that are present in the string of insulators and the voltage across the string, across the disc which is nearest to the line conductor. This is the string efficiency. If the string efficiency is maximum, then this voltage across all the insulator discs will remain same. But this is not the case. In practice, because of the presence of shunt capacitance, this string efficiency will not be 100%, or you can say the voltage distribution is not same, is not equal. Therefore, we have to adopt certain methods to improve this string efficiency. There are three methods. One is increasing the length of the cross arm. Second one is grading of insulators. And third one is using guard ring. So by using these three different methods, we can improve the string efficiency. Thereby, we can achieve the uniformity across uniform voltage distribution across all the discs in this string insulator. Okay, let us see one by one. First one is using longer cross arms. See here, this is a cross arm, this is the tower. Okay, now this is the tower, this is the cross arm. Okay, so just see the difference here. The cross arm is short here, but here we have used longer cross arm. Why? So as to take care of this shunt capacitor. C1 is equal to K into C, isn't it? So if you reduce the K, then you can improve the string efficiency. Okay, so how we can, by increasing the cross arm, what will happen? See, K is equal to C1 by C. Okay, if you decrease the K, then voltage distribution will be more uniform. So if you want to decrease the K, you have to decrease C1. How to decrease C1? What is C? C is equal to epsilon A by D, isn't it? So here epsilon, let us take it is a constant. A, let us take A is what? It is the area of the two conducting plates. That let us take that is also constant. Then what is variable? D. isn't it? If you increase the d, the distance between this and this, if we increase the d, then we can decrease the C1. If we decrease the C1, then the string efficiency will improve. Okay, but what is the disadvantage is we cannot increase this cross arm, too much. We cannot increase beyond certain limits. Why? If we increase this cross arm beyond certain length, then we have to use more stronger tower, which requires more material, and the cost will increase because of the imbalance. No, if it is increases beyond certain limit, then this becomes imbalanced. So this tower becomes mechanically weak. Therefore, we have to use stronger tower. If you want to use a stronger tower, then you have to use more materials, and the cost will increase. Therefore, this method is hardly used in practice. Okay. The next one is grading of insulator discs. What is this grading? This is the insulators. Okay. These are the different types of insulators. See, what is the grading of insulators? Grading of insulators is we have to use different size insulators for in a string. Okay, for example, this is of smaller size, this is slightly bigger than this size, bigger, like it goes on increasing. The size of the insulator disc goes on increasing from the top, that is nearer the disc which is very near to the cross arm will be having a smaller size, and the disc which is nearer to the line conductor will be bigger one. Why we do this? Just see here. This we have understood that the voltage which is across the disc which is nearest to the line conductor will be having maximum electrical stress, and this voltage goes on decreasing as we reach the cross arm. Okay, so if you want to equalize all these voltages, then this capacitance, because voltage is inversely proportional to the capacitor, V is equal to I into XC, isn't it? XC is equal to 1 by omega C. So that is, voltage is inversely proportional to the capacitance. So if you want to have more voltage, if you want to have more voltage, then the capacitor must be less. Okay. So the size of this capacitor should be less, and the size of this capacitor should be more compared to this. Okay, and the size of this should be bigger than these two. So what does it mean? This voltage, if the size of this capacitor disc is less, then this voltage will be more, and this, if this capacitor is bigger than this, then this voltage will be slightly lesser than this, slightly lesser than these two. That means the voltage is equally distributed. But what is the disadvantage? This we need to have a different sized more discs. So generally we don't adopt this. Okay, we don't use practically. The next one is using guard ring. So here, this is the guard ring. It is attached to this conductor. So there will be virtual capacitors between these links. This is a link, metal link. Okay, so there will be a virtual capacitor between this ring and this link. So this is such that the charging current I2 dash is equal to I2, I1 dash is equal to I1. So the charging current which is flowing through all these capacitor will remain same. Therefore, voltage across all these capacitors will remain same. This is how we can increase the string efficiency, thereby attaining